Good of viewers, this is Afiademola Johnson, your chemistry tutor and your biology tutor. Don't forget to share this video, like it, and subscribe. Now, we want to look at stoichiometry of chemical reactions. So you will be given equation. You'll be given a question from where you will derive an equation and you begin to use the equation to solve. So, and this part is of the following categories. So we have the following categories in this part. What are the categories of this? Now, number one, we have mass relationship. 2, we have mole relationship. You have mass mole relationship. Then you have mass volume relationship. Then you have mole volume relationship. And lastly, we have volume relationship. So we are going to take them one after the other to talk about them. Now, the first one we have there is mass relationship. What does mass relationship mean? It means in an question they will give to you, they will give you the mass of one part of the same equation, and you'll be asked to find the mass of another part of that equation. Now, let's look at mass relationship. Now, the formula suitably used is, now what do? The mass of A, which is the mass of what you are given, the mass given in your question, over molar mass of the same A is equal to mass of B that you are looking for over molar mass of B that you are also looking for. Let's look at an example. Examples number 1. You can be asked to find the mass of oxygen liberated during the thermal decomposition of potassium trioxochlorate 5, which is KClO3. Then you will be given potassium is 39, chlorine is 35.5, then oxygen is 16. Yes, this is the information, this is the question. The first thing to do here, okay, this question is not complete. You only determine the composition of, let's say, 5.2 gram of, so take note of that. So you'll be given a mass, you'll be asked to find mass. in the same balanced equation. So let's look at how to go about that. What do you do when you have this kind of question? First thing is to identify the type of relationship. And when you identify the relationship, then you know how to derive the formula. First, write the equation. They say find the mass. You are looking for mass of oxygen. Oxygen is representing your A now. Mass of A. Then use all this to find the molar mass of oxygen. So you will write the equation first. What is the equation? How do I get the equation? Oxygen is liberated. If we say liberate, it means it will be after the arrow. Oxygen is here. It will be liberated, and oxygen is a gas. Then what it will be here that will break down to form this. Now, liberated, that goes out during thermal decomposition. Thermal decomposition means the use of heat to break down something. Of 5.2 gram of what? KClO3. So it is KClO3 that is here. That breaks down to form oxygen, but it is not only oxygen that will be formed. So you should know that if oxygen lives here, you'll be left with KCl by yourself. Then you know that you should balance the equation. So then, how do we balance this equation? You have to balance it. Very important. To balance this equation, because I have 3 here, I will put 3 here. And I have 3 times 2, that's 6. So I need to put 2 here now, so that when I say 2 times 3, the oxygen is balanced. Then behind potassium I have 2. Behind chlorine I also have 2. So I have to put 2 here. Bam, I'm through. Then the next thing to do, identify the 2 key, there are 1, 2, 3 parts of this equation, but only 2 of them are important. Identify the 2 that are important. The 2 that are important include one of them that the mass is given, and the other one is the one you are looking for. Which one is the mass given? This 5.2 gram is of what? K potassium triacylchloride 5. And where is it? Which is this one? So find the molar mass of this one as it is. Then you have 2 here into what? Potassium is what? 39. According to what you have here. Then plus chlorine is what? 35.5. Then plus oxygen is what? 16 times 3. Then what will I do? I have 2 into, then I use my calculator. Now I have 39. This is 2 anyway, because of these 2 that I use to balance. That's the essence of balancing the equation. Okay, I have 16 times 3, 16 times 3. Answer is 48. So I can have 48 plus 35.5 plus 39. Answer is 122.5. Bracket close. Then we now have this one times 2. Answer is 245 gram. That is the molar mass of the 5.2 gram of KClO3 given. Then we also need to calculate the molar mass of the oxygen that they say you find. Find the mass of oxygen. So what do we need to do that? What do we need to do that? We write 3 here. Oxygen is 16, but you have 2 here. So what do? We have 16 times 2 is what? That's 32. 32 times 3. That's what we are looking for. 32 times 3 is 96 gram. That is 96 gram. So what do I have now? What do I do now? You now have what? Mass of KClO3 over molar mass of KClO3 equals to mass of O2 over molar mass of O2. So what is the mass of KClO3 given to us in the question? That's 5.2. 5.2. What is the molar mass we have gotten? 245. Then equals to what is the mass we are looking for? Mass of O2. What is the molar mass of O2? 96. So now we are looking for this, so we cross multiply. We have 245 mass of O2 is equal to 5.2 times 96. So what do we have? We now have mass of O2 equals to, then what do we have here? We have 5.2 times 96. Then our answer is 499.2. Then we divide it by 245. So our answer is divided by 245. Answer is 2.03 gram. 4 gram. So we are going to stop here. Please do try to subscribe and share this video. And in the next class, we will solve some other questions, more technical questions than this one in the next video. Please try to watch out for the next video. Then I remain my humble self, Afiademola Johnson. See you next time and God bless you. Bye. Thank you.